This video covers the chi-square goodness of fit test. So this is going to be a test if you have one set of categorical data and you want to see if they fit a certain distribution. So in this case, I want to know if the favorite colors of students in my class are equally distributed. So the first thing that I'm going to do before I even carry out the test is I'm going to check the assumptions. First assumption for every test is that I have a random sample. So in this case, I would need to have randomly chosen students, which is the case. For you, you probably have a random sample unless you disregarded some data or threw some data out or you skewed your data in some way, shape, or form, which is probably not what you did. The assumption is that the expected values have to be at least 5. In order to calculate the expected values, you do your sample size times the expected proportion. So if we go to our data set, out of the colors I gave students, if I look at a summary of those colors, I gave them 7 options to choose from. So if all of these colors were equally likely or equally favored, 1/7 of the students would like each color. So what I would do to find the expected values is I would do 29 times 1/7 for each category. That is not at least 5, so that's an issue. Hopefully you have a bigger sample size than I do, and yours are at least 5. If you don't, then you're going to need to talk to your mentor and figure out a different test to carry out. So let's just say that that assumption is met just for the purposes of carrying out this test. What I'm going to do next is I'm going to choose test. I want a goodness of fit test. I need to tell Fathom what it's looking at. It's looking at favorite color. So those are all of the actual values. So 14 students liked blue, 3 liked green, etc. Okay, I'm testing that the colors are not equally likely or have probabilities different from those given. I'm going to say not equally likely. If you have your own probabilities that you want to enter, you would change it to different from those given, and you would have to give some probabilities. But we're talking about not equally likely. We end up with a p-value of less than 0.0001. Because that p-value is less than 0.05, we have reason to believe that the colors are not equally favored. That does not tell us, though, which color is favored the most. In our data, it looks like blue, but we can't say that just based off of how the data looks. So this test will only tell you, are they equally likely or not? So we have reason to believe that favorite colors are not equally likely. I also said when I came to talk to you that generally a hypothesis test is followed up with a confidence interval. For chi-square, we do not do confidence intervals. At this point, if you're more interested in the specific relationships or which ones are not equal, you can talk to myself, Ms. Button, or your mentor, and we can figure out where to go from here.